In this lesson, we will discuss amplifiers. As I mentioned in the introduction to the course, this course is about amplifiers. So, what we will do in this lesson is to see the characteristics that an amplifying device must have. Okay? Now, in this lesson, we will not be looking at any amplifier device in particular, but only about general characteristics that amplifier devices must have. Okay? An amplifier has an input and an output. So, we will assume that it is a two-port network. Okay? So, to one of the ports we will feed the input, and from another port we take the output. And let me consider, just for simplicity, a 3-terminal 2-port network like this. You would have seen representations of such a 2-port in your basic electrical circuits class. And this is port 1, port 2, and this is the common terminal. Okay. Now, let us say that I apply a signal, let us say it is called V1 to port 1, and I will also write down the definition of port voltages and currents. Okay, V1 and I1 and V2 and I2 in the second port. And let us say that we take the output from the second port. Again, I have shown a voltage source here, but it does not have to be like this. It could have a series resistance, it could be a current source and so on, because all the arguments we will make now will be general and in terms of only the port variables. It does not matter what is actually connected to this side or this side. Okay. Now, every network that we take is passive, that is, it does not have a source of energy inside. It can only dissipate power. Okay. So, what does it mean? This 2-port network N, this is passive. So, it means that V1 I1 plus V2 I2 is going to be more than 0, or maybe it is equal to 0, in which case it is not dissipating any power. So, it cannot generate any power, it does not have any source of power inside. Okay. Now, what does it mean for our amplifier? First of all, we wanted amplification. What it means is that the power that we put into the amplifier P in must become bigger when it comes out. Okay. That is, for an amplifier, we would want P out, the power coming out, to be more than power going in. Okay. Otherwise, there is no amplification at all. Okay. So, this is what we would want to have. Now, let us see if our circuit can amplify power, because just now I said that all our networks are passive. Okay. So, that means that V1 I1 plus V2 I2 will be more than 0. Okay. So, now what is the input power P in? P in is V1 times I1. Okay. So, you see that the current flowing out of the positive terminal of V1 is I1. So, the power supplied by this voltage source, which is going into the port 1 of the network, that is V1 I1. And what is the power delivered into the load? That is the voltage across the load, which is V2 times the current flowing into the load according to the passive sign convention, which is minus I2. So, the output power is minus V2 I2. Remember, we chose the signs of V2 and I2 according to the passive sign convention. Okay. So, the power that is coming out of the 2 port is minus V2I2. Now, if you just rearrange this, okay, by taking V2I2 to the other side, you will easily see that minus V2I2 is less than or equal to V1I1. In other words, P out is less than or equal to P in. Okay. Now, this is not very surprising. Okay. This looks in fact like a roundabout way of saying that the device is dissipating power, because we already said that the device is passive. Okay. So, that means it is dissipating power, and remember, there is no other source of power here. The input V1 is the only source of power. Okay. So, whatever is coming out of the 2 port is less than or equal to, at most equal to, the power delivered by the source V1. Okay. Now, the reason I even showed these calculations is we will elaborate on this later. We have to make some other arrangement to amplify power. So, to get used to that, I have shown you these calculations, but the calculations basically show what common sense would have told you. There is only one source of power here, which is V1, and it is a passive network. So, it can only dissipate power. So, what can come out can only be less than what is going in through a single source of power. Okay.